This is my trigonometry course. Today we're going to learn the law of cosines. If you haven't done the homework completely incorrectly from the last class, do that homework before watching this video. In the previous classes, we learned how to use the law of sines to solve triangles in these scenarios here. Today we're going to learn how to use the law of cosines to solve a triangle when we're given the lengths of all three sides but no angle measures, and when we're given the lengths of two sides and the measure of the angle between those two sides. In both those situations we're going to use the law of cosines. The law of sines will not work in those situations, at least not in the first step. So here's the law of cosines. Go ahead and get a picture with your phone. It says if lowercase a, b, and c are the side lengths of a triangle, and uppercase a, b, and c are the interior angle measures, then the equations to the right are true. Now notice that there are three equations. These equations all pretty much say the same thing. The reason that we write three of them is to show that the law of cosines works for any of the sides of a triangle. Now, we don't usually show proofs in the math curriculum because you're not really required to know most proofs, and students typically get bored when you try to show proofs. But if you want to know the proof of the law of cosines, let's set up the proof and I'll show you the proof. We won't go through every step, but this is the altitude of the triangle, the height, and let's label the sides A, C, and B. And I'm going to label this segment X and this segment Y. And notice that this blue triangle here is a right triangle. We can generate these equations over here from the blue triangle. Those are just basic equations. And if we look at the yellow triangle, notice that it's a right triangle, as the blue triangle is a right triangle. If we use the Pythagorean theorem on the yellow triangle, we create this equation here, and if we use these blue equations, we can prove one of those equations, one of those three equations. This happens to be the bottom one. If you flip this triangle around, then you can prove the other two equations. But again, you're not required to do that. Let's get into some practice problems. This is what you are required to do. You need to know how to use the law of cosines to solve problems. So we're going to solve triangles when we have the lengths of two sides and the measure of an angle between the two sides first. That's the SAS situation. And it might be good for you to draw this triangle. It doesn't have to be a perfect drawing, but if you draw the triangle, it'll be easier to see what we're dealing with here. You may wonder, how do you know that we're given the lengths of two sides and the angle measured between the two sides? Well, you know because all these letters are different, and one of the letters is the measure of an angle, whereas the other letters are sides of the triangle. Now obviously the first question we need to ask is, what equation do we use? We have three equations. Which one do we use? Well, we're looking for the length of side B, so that means we're going to use this equation because we have B on the left side there. That's how you tell. So let's write the law of cosines. Now notice that we have a lowercase b here and an uppercase B here, and all of the other letters are in the middle. of the equation. So that's one way that you can remember. That's true for all three equations. So this is the law of cosines in this particular situation. So A is 14, C is 10. We're going to plug in A again and C again. And then we're going to plug in uppercase B, which is 19 degrees. So now all we have to do is simplify this expression and then square root, because we're looking for B, not B squared. Now I have to warn you that students have a lot of trouble simplifying this expression. They often will violate the order of operations, and it just causes a lot of confusion when students first use the law of cosines, but we're going to get a lot of practice, so don't worry about that. The most important thing to understand is that all of these terms here are multiplied together. Is that clear? All of these numbers, expressions, they're all multiplied together. So you cannot combine this expression with these expressions over here until you first multiply all of these. And when I say combine, I mean subtract. So you should be aware that the order of operations rules are just guidelines. You can actually violate the order of operations in some cases. For example, if you want to square these and then add them together, we're technically adding before we multiply all these terms. So it can be a little confusing. Again, the order of operations is a set of guidelines. It's not always necessary to follow the order of operations. But if you try to subtract 2 from 10 squared, that would definitely give you the wrong answer. So it can be very confusing. 14 squared is 196, 10 squared is 100. And I'm going to multiply all of these numbers. Generally, when doing these problems, if you're familiar with the math, you can go ahead and just multiply all of these at once. But we're going to take it slow here, and when we multiply, we're going to get 280. So all of those orange numbers became 280. Now again, the most important thing to understand is that these are multiplied together. So don't think about subtracting this term until you multiply those. So we get 296 minus, and now we need to go to the calculator. If you're using an iPhone, rotate into landscape mode and make sure that the button at the bottom left says rad. It should say rad. If it says DEG, then you're in the wrong angle measure. You need to change to where it says rad. So that button should say rad. If you're using a TI-84 Plus calculator or any TI calculator, push the mode button at the upper left and use the arrow keys to make sure that you're in degree units. Then push the blue button at the upper left, or the second button, whatever color it is, and push the mode button again, and that will quit out of that menu. So we're just verifying that we're in degree units. So now, remember, the order that you're going to enter the numbers is different depending on if you're using an iPhone or a graphing calculator. If you're using a graphing calculator, you're going to enter 280 times cosine 19 and then enter. If you're using an iPhone, you want to enter 280 times, then enter 19, then press the cosine button, and then press the equal button. So it's completely different. So I'm going to draw 3 green dots. And the reason I'm drawing 3 green dots is I want you to understand that we're going to keep this number in our calculator. So it's very important to understand that this entire expression became that number there. So now we just have to subtract. Now if you're using an iPhone, you can subtract this number from this number and then push the plus minus button to change to a positive number. If you're using a graphing calculator, you can enter 296 and then you can recall this number to make sure that you don't have to round off. So enter 296 and then press the blue button, and at the bottom right there should be a negative symbol with parentheses around it. It should say ANS. Press that button, then minus, then at the upper left push the blue button. It'll say second if it's not blue. Then at the bottom right press the negative symbol with parentheses around it. That's the answer button, ANS. Then enter. Then we get approximately, and by the way, this should be an approximately equal to symbol here. So we should get approximately 31.254, and you want to keep that number in your calculator. So we have b squared. We found b squared. The problem is we don't want b squared. We want b. So we're going to have to do the opposite of squaring, which is square rooting. And remember, whenever you square root both sides of an equation, you always write a plus or minus symbol. Now in this case, we're not going to need the plus and minus symbol, but it's probably good to get in the habit of writing a plus or minus symbol. So if you're using your iPhone, you can press this button, and it'll immediately give you the answer. That's assuming that you kept this number in your calculator. If you didn't, you can go back and recalculate. In a graphing calculator, you're going to, at least with the TI-84 Plus, you're going to press the blue button at the upper left, the blue second button, then the x squared button in the middle left, then the blue button again, and then the button at the bottom right, the negative symbol with parentheses around it. It should say ANS in blue, and then press the enter button. So B is approximately equal to plus or minus 5.590599. Now again, we're not going to need the plus or minus symbol because in this class we're not going to have any sides that are negative. In the real world, you don't really have negative sides for triangles or any geometric shapes, really. You only deal with negative numbers if you're using vectors or moving triangles into different quadrants when we define the trigonometric functions. Generally, in the real world, you don't have negative sides of geometric figures. So we found the length of b, and because we have the length of b, we can now use the law of sines, that law that we learned in previous classes, to find the measure of angle c. But whenever you use the law of sines to find the measure of an angle, you always have to consider that your calculator may give you the wrong number. Your calculator is programmed to give you the measure of an angle that terminates in the first quadrant when you're using the sine function, assuming that the ratio is always positive, and it is in this in these examples today. So your calculator may deceive you. If you try to find the measure of angle A first before you find the measure of angle C, then your calculator is going to give you the wrong number in this particular example. It's going to give you the measure of an angle that terminates in the first quadrant, whereas the angle A actually terminates in the second quadrant. So we're not going to find the measure of angle A in the second step. We're going to find the measure of angle C. But how do I know to find the measure of angle C first? Well, angle C is opposite the shorter side. That's how we know. Side C is shorter than side A. Do you agree with that? Okay, so that's how I know to find the measure of angle C first. Now, that is the most important thing that you need to learn today. In the second step, you're going to find the measure of the angle that is opposite the shorter side. If you remember anything in today's class, I want you to remember that. In the second step, you're going to find the measure of the angle that is opposite the shorter side. Because if you find the measure of the angle opposite the longer side, your calculator may give you the wrong number. And the reason for that is the angle opposite this shorter side must be acute. So we know our calculator is going to give us the right answer. If this triangle is an obtuse triangle, that means that there's one obtuse angle, only one. There can only be one obtuse angle in a triangle. And remember, obtuse means greater than 90 degrees. And we learned in my geometry course that the size of the sides of the triangle, the lengths of the sides of the triangle, are related to the angles opposite those sides. And what that means in simple terms is the obtuse angle, the angle that is greater than 90 degrees, if there is an angle greater than 90 degrees in this triangle, it will always be opposite the longest side. So if there's an angle in the triangle greater than 90 degrees, it must always be opposite the longest side. So if we find the measure of the angle opposite a side that is not the longest side, then we know that that angle has to be acute. And so the number that our calculator will give us will be the right number, because when the sign value is always a positive number, which in this case it always is, when you're using the law of sines, your calculator is going to always give you an acute angle, the measure of an acute angle. So I know that's kind of complicated to think about all that, but that is the explanation. Okay, so sine C over C is equal to sine B over B. Again, the reason I use this ratio is I know that this side is shorter than side A. So we're looking for the measure of angle C. We know side C is 10. Angle B is 19 degrees. And side B we found is 5.590599. And technically that should be an approximately equal to symbol. And we can move this stuff a little bit. So to solve this equation, we simply multiply both sides by 10. And we get 10 sine 19 degrees over 5.590599. And let's use the calculators. Be aware that the order that you enter numbers with a graphing calculator is going to be completely different from the order of the numbers that you enter in an iPhone. So be aware of that. In a graphing calculator, we're going to enter 10 times sine 19 and then enter, and then divided by 5.590599. Enter, and then we get approximately 0.5823, and I'm going to write 3 green dots, which means you want to keep that in your calculator. Now, if you have the iPhone, you can just press the sine inverse button. You have to push the second button at the upper left first to change the sine function to sine inverse. And just press that sine inverse button and it'll give you your answer immediately. In a graphing calculator, push the blue button at the upper left, which says second, then the sign button, then the blue button again, and then the negative symbol with parentheses at the bottom right of the calculator. So it should say sine inverse ANS, and then press enter. So the measure of angle C is approximately 35.61595 degrees. And the reason I'm being so precise with these numbers is we're going to use these numbers in other calculations. So now we're going to use the triangle sum theorem to find the measure of angle A. Looks like we're looking for. The measure of angle B we were given is 19 degrees. The measure of angle C is 35.61595 degrees. So on our calculator, let's do the math. And we get 125.38, and we don't have to carry out so many digits because we're in the last step of the problem. We're not going to use this number in any further calculations. So there you go. That's how we use the law of cosines. Notice that we only use the law in the first step. Now, many people will tell you that it's better to use the law of cosines in the second step also, and you can do that, but the problem is it's very difficult to demonstrate that. It takes a long time, and you have to enter a rounded off number into these equations, and you have to solve a more difficult trigonometric equation, and it just takes forever to demonstrate that. The reason that people tell you to use the law of cosines in the second step is that you don't have to worry about your calculator tricking you. But again, it's not really realistic to do that because unless you know how to use this formula really easily, and again, it's really not easy to use that formula even if you're familiar with it. It's not easy to put those numbers into your calculator, so this is the best method. But again, the most important thing to know today is that when you find the measure of the angle in the second step, you need to find the measure of the angle which is opposite the shorter side. Then your calculator will not fool you. Alright? In this case, don't find the measure of angle A in the second step, find the measure of angle C. Then your calculator will not fool you. So in the next problem, notice that angle A is an obtuse angle, 100 degrees. And remember, if a triangle has an obtuse angle, there can only be one obtuse angle. It's impossible for a triangle to have more than one obtuse angles. So if angle A is obtuse, that means that angle B and C that we're going to find in the second and third steps must be acute. So we don't have to worry about our calculators deceiving us when we use the law of sines in steps 2 and 3. We're looking for the length of side A because we have the measure of angle A. So we're going to use the first equation. So let's go ahead and write that down. And let's plug in numbers. And as I mentioned in the previous problem, students often have trouble simplifying this expression. So let's do this together. Don't be afraid to use your calculator. 1.6 squared is 2.56. 3.4 squared is 11.56, and 2 times 1.6 times 3.4 is 10.88. And we can add 2.56 and 11.56. And we get 14.12. And let's calculate cosine 100 degrees. Normally we would just multiply these together, but cosine 100 degrees is going to be a negative number because 100 degrees is an obtuse angle. So I'm going to go ahead and show that, and we want to keep this number in our calculator for now. So then we're going to multiply that number by negative 10.88, and we get 1.88. So again, in these situations, you're going to be multiplying two negative numbers. Again, that's when the angle is obtuse, and you're going to get a positive number. So now we're going to add that to 14.12, and we get 16.009. You want to keep that number in your calculator. And technically these should be approximately equal to symbols. I know it's kind of tedious to have to keep writing approximately equal to. So now you're going to press the blue button in your TI-84 Plus at the upper left, and then the X squared button at the middle left, and the blue button again, and then the negative symbol with parentheses around it at the bottom right, and you should get something that looks like this. And that number is going to be about 4, and our units are inches. If you're using an iPhone, you want to press this button. Let's carry out some extra digits here because we're going to use that number in later parts of this problem. And we want to keep that number in our calculators, but that is one of the answers, so we're going to write our units. So now we're going to use the law of sines. We could use the law of cosines, and that would ensure that our calculator would not fool us. Whenever we use the law of cosines, we don't have to worry about our calculator fooling us. The problem is using the law of cosines can be kind of tedious. That's a lot of work we have to do, especially if we have to show the work. I'm not going to require you to show every step, but I'm showing every step here, so that's a lot of work. So I'm going to use the law of sines, but when you use the law of sines, you have to be aware that your calculator may give you an angle that is not correct. It might give you an acute angle when the answer is actually obtuse. But we don't have to worry about that in this problem because we know that the measure of angle A is 100 degrees, so we know that A is an obtuse angle. And the reason that that helps us is because if there is an obtuse angle in a triangle, there can only be one obtuse angle in any triangle. You cannot have more than one obtuse angle. So that means that if this angle is obtuse, these angles that we have to find in the next steps, they have to be acute. So our calculator is not going to fool us. So let's use the law of sines to find the measure of angle B. And we can put a divider here and plug in numbers. So the measure of angle B is what we're looking for, and we know side B is 1.6, and we know the measure of angle A is 100 degrees, and the length of side A we just found is 4.00116, and you want that number to still be in your calculator. So now we're going to multiply both sides of the equation by 1.6, and we get approximately 1.6 sine 100 degrees over 4.00116. So you can use parentheses in your calculator. Parenthesis 1.6 1.6 times sine 100 parenthesis divided by the answer, and use the blue second button at the upper left and the negative symbol with parentheses around it at the bottom right on your TI-84 plus if you're using that calculator. If you're using an iPhone, then you can divide this number by this number and then divide that result by sine 100, and then you can push the 1 over x button to flip everything around. So there are ways to do it. 0.3938 approximately is the number we get there. And to find the measure of angle B, we're going to use the sine inverse button on our calculators. And we get 23.19 approximately. 23.1917 degrees. We're going to keep that number in our calculator, but that's one of our answers. And so now we're going to use the triangle sum theorem to find the remaining angle. So the measure of angle A is 100 degrees. The measure of angle B is 23.1917 degrees. And so we're going to subtract 23.1917 degrees from 180. And we're going to subtract 100 from that, and we get approximately 56.8 degrees. And we don't really have to carry out a lot of digits because this is the last number that we have to find, so we don't have to worry about round off error. So if you got that right, excellent. So let's go ahead and go on to the next problem. Okay, so now it says find the length of side C. So now we're going to use C squared is equal to A squared plus B squared minus 2AB cosine capital C. So notice that this looks exactly like the Pythagorean theorem. We just have this little modification here. Again, we have lowercase c and uppercase c, and then all of the other letters are different. So that's one way that you can remember that formula. It's the same for all three formulas. So now we're just going to plug in numbers. A is 7.2, B is 8, A is again 7.2, B again is 8, and capital C is 57 degrees. Now we just have to simplify this expression, but I have to warn you that, again, students typically have a lot of trouble simplifying. Don't be afraid to use your calculator. 7.2 squared is 51.84, and we have 64. 2 times 7.2, and then times 8, and I'm going to go ahead and multiply cosine 57. So I'm going to multiply all of these together, and we get 62.742. And 2 times 7.2 times 8 is 115.2, and then we're going to add the first numbers. 51.84 plus 64 is 115.84. So all these combine to that, and this product is going to combine to whatever goes there. So 115.2 times cosine 57, and then enter, and we get 62.742, and it just goes on and on and on. So now, again, if you're using your iPhone, you can subtract this number from this number, and then plus minus button. Well, that'll change it to a positive number. With the graphing calculator, enter 115.84, and then minus, then the blue button at the upper left, and then the negative symbol with parentheses at the bottom right. Enter, and we get approximately approximately 53.09758. Keep that number in your calculator. We found c squared, but we don't want c squared. We want c, so we're going to square root both sides. And remember, we don't need the plus or minus symbol. So with the iPhone, you're going to press this button, and with the TI-84 Plus, you're going to press the blue button at the upper left, and then the X squared button in the middle left, and then the blue button again, and then the negative symbol with parentheses at the bottom right. So C is approximately equal to 7.2868, 7.2868, and the units are centimeters. So we found lowercase c, and I'm going to make that a little c just so we don't confuse that. Okay, so now we're going to use the law of sines to find our first angle measure that we need to find. But we need to find the measure of angle A before we find the measure of angle B, because angle A is opposite the shorter side, which means that it has to be an acute angle. So when we use our calculator to find the measure of angle A, it's going to give us the actual number we're looking for. So sine A over A is equal to sine C over C. We have C down here. Plug in A is 7.2, and C is 57 degrees, and we have 7.2868. Multiply both sides of the equation by 7.2, and this should be technically approximately equal to, we can use our calculators, 7.2 times sine 57, enter, then divided by 7.2868, and then enter. So sine A is approximately equal to 0.82868, and keep that number in your calculator. And so A is approximately equal to sine inverse of that number. So I'm going to press the blue button and the sine button, and then the blue button again, and then the negative symbol with parentheses around it at the bottom right, and then enter. And we get 55.963, 55.9634 degrees, and you want to keep that number in your calculator. And of course we're going to use the triangle sum theorem. We're looking for, well, we got the measure of angle A. And the measure of angle C is 57. So 180 minus 55.9634, and then minus 57. And the measure of angle B is approximately 67 degrees, and I'm just going to round it off to 67 because we're in the last step. The last step of the problem. So we used all three forms. I know that took a long time, but we used all three forms of the law of cosines. So at this point you should have a pretty good idea of how to do the math. And you may think that, well, that was a lot of work. I don't know why we had to do that over and over again, but the reason we have to do it over and over again is because students have so much trouble with the order of operations when simplifying that expression. So now it's time for you to try. You're going to use the equation that starts with a squared. So that is going to be the first equation. So I'm going to give you a chance to take a picture of the law of cosines again. You're going to use this first equation in the first step. And then you're going to use the law of sines in the second step, and you're going to make sure to find the measure of angle B first, because that side is opposite the shorter side, so we know that that angle is an acute angle. And our calculator will not deceive us. So go ahead and try number 4. When you come back, we'll do it together. Okay, we're back. So let's write the law of cosines. And we're going to plug in numbers. So B is 5.9, C is 12, and A is 38 degrees. So again, for students, the hardest part of this problem is simplifying this equation. So don't be afraid to use your calculator. 5.9 squared is 34.81. 12 squared is 144. 2 times 5.9 times 12 is 141.6. So we're going to combine these terms. We're going to add those up. 34.81 plus 144 is 178.81. And then we're going to subtract all of this. 141.6 times cosine 38, and then enter. And we get 101.5823, and we want to keep that number in our calculator. And again, if you're using an iPhone, you want to subtract this number from this number and push the plus minus button. In a graphing calculator, you're going to enter 178.81, then minus the at the upper left of the blue button, and then the bottom right button that has a negative symbol with parentheses, and then enter. And so a squared is approximately equal to 67.2276. And we're going to keep that number in our calculator. Then we're going to square root both sides. We get 8.199 approximately, and that's going to be millimeters. So if you got that right, good. Now, here comes the part that's crucial. It's important that we find the measure of angle B first before we find the measure of angle C. That way our calculator won't deceive us when we use the law of sines. So sine B over B is equal to sine A over A. We have 5.9 for B and 38 degrees for A. And we found the length of A is 8.1992. Multiply both sides by 5.9. And we've done this quite a bit today, so I don't think you need to see every step of that. So we have 5.9 times sine 38, enter, and then divided by 8.1992, enter, and we get approximately 0.443. Keep that number in your calculator, and B is approximately equal to sine inverse of that number. Keep that in your calculator. So this blue button at the upper left, the sine button, the blue button again, and the negative symbol at the bottom right with parentheses around it. Enter, and you get 26. That's if you're using a graphing calculator. And you're going to keep that number in your calculator. That's one of our answers. And we have the measure of angle A is 38 degrees. The measure of angle B we just found. So 180 minus 26.29667 minus 38, and we get approximately 115.7 degrees. And again, technically this should be approximately equal to 180. So if you got that right, excellent. Okay, so now try number 5. In this case, you're going to use b squared is equal to a squared plus c squared, so on and so forth. So you're going to use the second equation. So try number 5, and when you come back, we'll do it together. Okay, we're back. So we have the measure of angle B. So we're going to use this variation of the law of cosines. And A is 8, C is 4.5. The measure of angle B is 128 degrees. So 8 squared is 64. 4.5 squared is 20.25. 16 times 4.5 That's going to be 72. So you don't have to show every step as I'm doing here, but this is just for your benefit so you can see how to simplify. So we get 84.25. And cosine 128. That's going to be a negative number. It's negative 0.61566. And you want to keep that number in your calculator for now. Multiply that by negative 72. And technically that should be an approximately equal to symbol. So here we get positive 44.3276. Keep that number in your calculator for now. And then add that to 84.25. And we get 128.5776. Keep that number in your calculator. Square root both sides. And we get 11.3392. You want to keep that number in your calculator. And that's one of our answers. That's going to be in kilometers. Now we're going to use the law of sines to find the measure of these angles. But remember, whenever you use the law of sines to find the measure of an angle, you always have to be aware that your calculator may give you the wrong answer. But in this case, we know that the measure of angle B is 128 degrees, and there can only be one obtuse angle in a triangle, and that's the obtuse angle. So we know that our calculator is going to give us the right answer. Because we know that these remaining angles must be acute. So we're going to use sine C over C is equal to sine B over B. So we're looking for the measure of angle C. We know side C is 4.5. And measure of angle B is 128 degrees. And we just found side B. You want to keep that number in your calculator without rounding it off. And then we're going to solve for sine C. So we just multiply both sides of the equation by 4.5. Again, you want to keep that number in your calculator if you can. And we're going to enter 4.5. Well, just to be careful, I'm going to use a parenthesis and then 4.5 sine 128, then another parenthesis and another parenthesis, and divided by the answer using the blue second button and the button at the bottom right with the negative symbol. So sine is approximately equal to, sine C that is approximately equal to 0.3127. And then we're going to look for the measure of angle C. So to find that, we need to use the sine inverse button. And again, you want to keep that number in your calculator. So sine inverse of the answer is equal to 18.22 approximately. So C is approximately equal to 18.2235 degrees, and you want to keep that number in your calculator. So now we're going to use the triangle sum theorem. The measure of angle B is 128 degrees, we know that. The measure of angle C we just found is 18.2235 degrees. And that's approximately equal to 180 degrees. And we're looking for the measure of angle A. So 180 minus the answer, 18.2235, and then minus 128. And we see that A is approximately equal to 33.77 degrees, and we can use our own discretion when rounding off because this is the last part of the problem. So we don't have to worry about carrying out a lot of digits. So if you got that right, good job. Actually, let's round up here. There we go. And let's rectangle this answer here. That's part of our answer. Okay, so let's go on to number 6. Go ahead and try number 6. And again, they give you the obtuse angle in these examples. So if they give you the obtuse angle, you know that all these angles must be acute. So you don't really have to worry about your calculator giving you the wrong number. Try number 6, and when you come back, we'll do it together. Okay, we're back. So we have the measure of angle C. So we're going to use this variation of the law of cosines. And we're looking for the length of side C, so we're going to plug in A is 18 and B is 23. And so now let's calculate. 18 squared is 324, and 23 squared is 529, and we multiply all these numbers, we get 828. And now let's add 324 and 529. And we get 853. And cosine 142 is going to be a negative number. If this number is if this is an acute angle, then we're always going to get a negative number. And we want to keep that number in our calculator and multiply it by negative 828. And then we get a positive number, 652.4729. Keep that number in your calculator and add that to 853, and we get 1,505.472. Keep that number in your calculator and then square root both sides. And we get the length of side C, 38.8004, and you want to keep that number in your calculator, and that's going to be miles. Be sure to write your units. Okay, so now we're going to find the measure of angle A, and again, we don't have to worry about our calculator deceiving us, because we already found, or we already know the measure of, we know that this is an obtuse angle. So all of these angles we know are going to be acute. So we don't have to worry about our calculator giving us the wrong numbers when we're using the law of sines to find an angle. So sine A over A is equal to sine C over C. And we're looking for the measure of angle A. We know side A is 18. And the measure of angle C is 142 degrees. We know that. And we just found the length of side C, which is 38.8. And we need to keep that number in our calculator without rounding off. So we'll multiply both sides of the equation by 18. And so we can use a parenthesis, 18 times sine 142, parenthesis, parenthesis, and then divided by the answer. So push the second blue button and then the negative symbol with parentheses at the bottom right, and then enter. And we see that sine A is approximately equal to 0.2856, and keep that number in your calculator. And then A is going to be approximately equal to 0.2856. Keep that number in your calculator. And so we get 16.59 approximately. 16.5954 degrees. And you want to keep that number in your calculator. And now we're going to use the triangle sum theorem, of course. So the measure of angle A is 16.5954 degrees. The measure of angle B is what we're looking for. And we know the measure of angle C is 142 degrees. And that should be an approximately equal to symbol. So now let's do the math. And we get 21 degrees for the measure of angle B. And we can use our own discretion when rounding off. So there you go. So if you got that one right, good job. Okay, let's go on to the next problem. So you should be fairly familiar with the law of cosine equations at this point. And now we're going to move to the SSS scenario. So that's when we have the lengths of all three sides of the triangle, but we don't have any angle measures. In that situation, we're going to have to use the law of cosines, because the law of sines just doesn't work. So the question is, what version of the law of cosines do we use? Well, in order to help us to avoid any misunderstanding with our calculator, because again, whenever you find the measure of an angle with the law of sines using your calculator may give you the wrong answer. So in order to avoid that, we want to find the measure of the angle that is opposite the longest side. that eliminates any possibility that our calculator will fool us, because our calculator will always give us the measure of the angle that terminates in the first quadrant if we're using the law of sines. So if there is an obtuse angle, it's going to be opposite the longest side. And when you use the law of cosines, the angle that you are given will always be the proper angle. That's not true for the law of sines, but with the law of cosines, it will always give you the right angle. So we're going to find the measure of angle A first, because A is opposite the longest side. So if we're looking for the measure of angle A, we obviously have to use the equation that has angle A inside it, or the measure of angle A inside it, and that's this angle here. So we're looking for capital A in this case. So we have the same type of equation that we've been using, but our unknowns are going to be different. So we're plugging in numbers just like we did in the previous problems. But notice that we actually know what that number is at the left. It's 4.1. So let's double check, make sure we did everything correctly, or we plugged everything in correctly. Everything looks right. So now let's square 4.1, and we get 16.81. And 3 squared is 9, 2.1 squared is 4.41. And 2 times 3 is 6, times 2.1 is 12.6. And now we have a trigonometric equation. It's a little more complicated than, well, it's not really more complicated, it's just different from the trigonometric equations that we have with the law of sines. So 9 plus 4.41 is 13.41. So all of this combined to that, or they added up to that. And we can't do anything with this because our variable is in the cosine function, so we're just going to have to leave that for now. So again, we just have a trigonometric equation here, and how do we do this? Well, we have to isolate the cosine A. We have to get it by itself. It's not by itself because this negative 12.6 is next to it and the 13.41 is next to it. So I'm going to subtract 13.41 from both sides. Now, you don't have to show this, but again, the purpose of this class is to demonstrate how to do things. Even though this is just a basic operation, some students get confused by all these weird expressions. So 16.81 minus 13.41 on the left side is 3.4. And these cancel out, and you're left with negative 12.6 cosine A. So now we have to divide both sides by negative 12.6. So 3.4 divided by negative 12.6 is going to be negative 0.2698, and you want to keep that number in your calculator, and that's approximately equal to cosine A. So now we're going to find the measure of angle A. We're going to use the cosine inverse button. So when you enter this into your iPhone, you want to enter 3.4 divided by 12.6, then the plus minus button, and then equals. In a graphing calculator, if you didn't get this number, then you may have to use parentheses around the negative 12.6 just to be careful. And you want to use the negative button at the bottom right with parentheses around it. Don't use the negative button at the right. You want to use the negative button with the parentheses around it. So we're going to press the blue button, then the cosine button, then the blue button again, and at the bottom right the negative symbol with parentheses. So we should have cosine -1 a and s, cosine inverse of the answer. And we actually got an obtuse, or the angle measure of an obtuse angle. So A is approximately 105.6548. So that's how you use the law of cosines when we have the SSS situation. You have to solve a trigonometric equation. So now we're going to use the law of sines just as we did with the previous problems, but now we're not really afraid that we're going to get the wrong number in our calculator, because we already found the one obtuse angle that could possibly exist in the triangle. So all the other angles are going to be acute, and that's what your calculator is going to give you. So now we can use sine A over A, because we have the length of side A they gave us here, and we have the measure of angle A. And it doesn't matter if we find the measure of angle C first or the measure of angle B first, but it tells us to find the measure of angle C, so we'll just use that. So sine of the measure of the angle we found in the first step, that's going to be 105.6548 degrees over the length of A, which is 4.1, is approximately equal to sine of the measure of angle C, which we don't know, over the length of C, which is 2.1. So I'm going to move this over a little bit. So we can multiply both sides of the equation by 2.1, and you've seen this quite a bit, so you don't really need me to demonstrate it anymore. Sine C is equal to 2.1 times sine 105.6548, and then enter, and then divided by 4.1, and then enter. So we get approximately 0.4931, and you want to keep that number in your calculator. And the measure of angle C is approximately equal to sine inverse of that number, sorry we keep running out of room there. So the blue button, the sine button, the blue button, and then bottom right negative symbol with parentheses, enter. So C is approximately equal to 29.5508 degrees, and keep that number in your calculator. And then at that point we can just use the triangle sum theorem. All the measures in a triangle, the angle measures, have to add up to 180. So the measure of angle A we found is approximately 105.6548 degrees. The measure of angle B we're looking for, and the measure of angle C is approximately 29.5508 degrees. And that's approximately equal to 180 degrees. Sorry, we keep running out of room there. So 180 minus 29.5508, and then minus 105.6548. Enter. And the measure of angle B is approximately equal to 44.79 degrees. We don't have to write so many digits to the right of the decimal because we're at the last step of the problem. So again, notice that I found the obtuse angle in the first step, and that guaranteed that when we use the law of sines, we would have acute angles. So the calculator would never give us an acute angle when it's supposed to be an obtuse angle. So it's very important that you find the measure of the angle that is opposite the longest side in the first step with these particular problems. I know that's very complicated to have to remember, but just understand that whenever you use the law of sines to find the measure of an angle, your calculator may deceive you. So let's try another one of these problems. So notice that B is the longest side, 3 centimeters. So if we use the law of cosines to find angle B, we know that angle will be the obtuse angle if there is an obtuse angle. And then we don't have to worry about our calculator giving us the wrong number when we use the law of sines. So we're going to purposely find the measure of angle B using the law of cosines first, so we can avoid that confusion. So now we're looking for the measure of angle B, so that means we're going to use this version of the law of cosines. And B is 3, A is 2, and C is 2.4. And we're looking for the measure of angle B. So it's always good to go back and make sure that we wrote everything correctly, because if you didn't, it's going to be a big waste of time to enter all this or do all this math. So it looks like we entered everything correctly. So 3 squared is 9, 2 squared is 4, 2.4 squared is 5.76, and 2 times 2 is 4. 4 times 2.4 is 9.6, and 4 plus 5.76 is 9.76. So we have a trigonometric equation that we have to solve, which means we have to isolate cosine B. So all these numbers became 9.76. So as you could see over here, we had to subtract 3.41 from both sides of the equation. So we can show that if you'd like. You don't have to show it, but just to be clear what we're doing here, I'm going to show it. Again, when you do these problems, you don't have to show that. That's just basic math. But students tend to get really confused with this stuff, so we're going to show that. Okay, so 9 minus 9.76 is negative 0.76, and that 9.76's cancel out, and now we have to divide both sides of the equation by negative 9.6, because negative 9.6 is multiplied into the cosine B. So 0.76 divided by 9.6 is 0.07916, and it just keeps going on and on and on. You want to keep that number in your calculator. And we have cosine B, and that should technically be approximately equal to. So B is approximately equal to cosine inverse of that number. And sorry, I have to keep moving this over. That should be the number from our calculator to avoid any round off error. So we're going to get 85 degrees approximately. 85.4593 degrees. Now, if there were an obtuse angle, this would be it, because this side, this angle is opposite the longest side. But as you can see, it's not an obtuse angle. It's less than 90, so it's an acute angle, which means that the triangle is an acute triangle. It doesn't have an obtuse angle. So we don't have to worry at all about our calculator fooling us when we use the law of sines, because there are no obtuse angles. So we're looking for the measure of angle A, and we don't really care if we find the measure of angle C first or the measure of angle A in the second step, because again, if there were an obtuse angle, we would have already found it. And we have information about angle B, so we're going to use sine B over B. So we're looking for the measure of angle A. We have the length of A, and we have the measure of angle B. It's 85.45. Sorry, that's one note throwing us around. 85.45 93 over the length of B, which is 3. And technically that's approximately equal to. Okay, so you've seen this many times, so we don't really have to show the algebra. We're going to multiply both sides by 2, and we have 2 times sine 85.45 93, and then enter, and divided by 3, and then enter. So we have 0.66457, and we're going to keep that number in our calculators. And A is approximately equal to sine inverse of that number. So the blue button, the sine button, the blue button, and the negative symbol with parentheses around it, and then enter. That's if you're using a TI 84 plus. So A is approximately equal to 41.6496. That's probably good enough in terms of the precision. So now we're going to use the triangle sum theorem. And we know the measure of angle A is 41.6496, and the measure of angle B we found in the first step is 85.4593, and we're looking for the measure of angle C. all that is approximately equal to 180. So 180 minus 41.64966 and minus 85.4593, enter. And so the measure of angle C is 52.89 degrees. That's good enough accuracy because we're at the last step of the problem. So I want you to go ahead and get a screenshot of these problems. You're going to use these problems to do number 9. These problems will help you. Now remember, you're going to start by finding the measure of the angle that is opposite the longest side, because if there is an obtuse angle, you want to find that angle with the law of cosines. That way you don't have to worry about your calculator deceiving you when you find the other angles using the law of sines. Whenever you find the measure of an angle using the law of sines, you have to worry about the angle deceiving you, giving you the wrong angle measure. So that's why we're going to find the measure of angle C first, because it's the angle opposite the longest side. And if there is an obtuse angle, that is going to be it. Okay, so go ahead and try number 9. When you come back, we'll do it together. Okay, we're back, so we don't have time to go through every single step, so I'm just going to show you the answers. So that's the answer for number 9. And now, go ahead and do number 10. You can use number 9 to help you. We're looking for the measure of angle B, because angle B is opposite the longest side. So if there is an obtuse angle, we're going to find it with the law of cosines. And so we don't have to worry about our calculator deceiving us when we use the law of sines in the second step. So go ahead and try number 10, and when you come back, we'll do it together. So we don't have time to show every step, but here's the answer. You can check that answer. If you made a mistake, that's okay. Just go back and figure out what you did wrong. So if you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3 and 4 and 5 and 6. But don't go before you get your homework. Here's the homework. Screenshot number 1, number 2, number 3, and number 4. So remember, if you don't do that homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done completely, correctly, neatly, and keep it in order in your binder. And I'll look forward to seeing you in the next class.